I hope you all are fine. As you know that we are discussing unit hydrocarbon. In that we have done alkanes and we completed alkenes also. So today we will start alkynes. Students, alkynes. You know very well alkynes mean carbon to carbon triple bond. Carbon to carbon triple bond should be there. If I talk about hybridization, number of bonded atoms. If I talk about this carbon only. So bonded atoms, how many? One this hydrogen, one this hydrogen, and one this group are attached with this carbon. So bonded atoms are two only. Lone pair, no one. Lone pairs are 0. Lone pairs are 0. So hybridization number of bonded atom plus lone pair. It is 2. For 2, hybridization will be sp. Simply you can also tell if triple bond, carbon to carbon triple bond, then hybridization will be sp. If carbon to carbon double bond, then hybridization will be sp2. And if single bond there, then sp3. So students, in case of alkyne, sp hybridization, and what will be the structures? Geometry will be linear. What will be the geometry for this one? Linear. Linear. Here, this one carbon, this one carbon. This carbon is forming one sigma bond with this hydrogen and one sigma bond with this carbon. One sigma bond with this carbon. Okay. Then students, this one also making one sigma bond with this hydrogen, one with this carbon. Here two pi bonds. Pi bonds means unhybridized orbitals. Pi bonds mean unhybridized orbitals. So these are making pi bonds. Two pi bonds are there. Clear or not? In this way you can make. So there are two pi bonds and one. This is sigma and these two are pi bonds. This is sigma. Clear or not? Now students, how can we prepare alkynes? How can we, Badal? How can we prepare alkynes? Method of preparation. First one from calcium carbide. Calcium carbide. Calcium carbide students means CaC2. CaC2. First of all, how can you obtain calcium carbonate? How can you obtain calcium carbonate? You have CaCO3, calcium carbonate. This is the calcium carbonate, and this is also known as the limestone. It is also known as the limestone. If it is heated, then it gives us decomposition reaction, and students, it decompose into calcium oxide. Calcium oxide plus carbon dioxide. Calcium oxide is also known as the quicklime. quicklime. If we have limestone, calcium carbonate, if it is heated, then it shows decomposition reaction and it decompose and gives us calcium oxide, means quicklime, and carbon dioxide. Then this one calcium oxide. This calcium oxide react with coke. This react with coke. And it gives us calcium carbide. It gives us calcium carbide. Plus carbon monoxide, CO. You can balance. Clear? In this way, you get calcium carbide from quicklime, and you get quicklime from limestone. Clear? Finally, if this calcium carbide hydrolyze, means react with water, 2 molecule we will use. Then what will happen, students? I can write water wait a minute. If this calcium carbide hydrolyzed, means water can be decomposed into H plus and OH negative. Then 2C2, these are replaced by the OH, and you can get the calcium oxide, calcium hydroxide, and calcium hydroxide also known as the slaked lime. CaO, quicklime. Calcium oxide is quicklime. Okay. And CaOH2, that is the slaked lime. Means when we add some water in quicklime, then it convert into the slaked lime. Okay. And CaCO3, that is the limestone. You know, after 2 or 3 days of the whitewash, you can see shining on the walls. Why it is? It is due to the formation of calcium carbonate. First you have calcium oxide, the whitewash which you apply on your walls, that is the calcium oxide. When it reacts with water, what will you do? Before applying, you will add water into that paste. In that, then this is the calcium hydroxide, that is the calcium hydroxide. And student, when calcium hydroxide you will apply on your walls, then it will react with carbon dioxide present in atmosphere, and after reacting with calcium hydroxide with the carbon dioxide, it gives us limestone, CaCO3, calcium carbonate. And due to formation of that, we get shining on the surface. I think it will take some more time. लग गया होगा, बट ज्यादा ही टाइम ले रहा है. Yes. Then students, water can give us H positive and OH negative. There are 2 molecules, So they can give just calcium hydroxide plus C2 and 2 C2H2. Ethyne we get. Ethyne we get. Because we want to form alkyne. So students, from calcium carbide we can get ethyne. From calcium carbide we can get ethyne. First, when calcium carbonate is heated, limestone is heated, then it gives us calcium oxide and carbon dioxide. When calcium oxide react with coke, then it gives us calcium carbide. Okay, and from calcium carbide we can get ethyne. When calcium carbide react with the water, then it gives us calcium hydroxide and ethyne. Calcium hydroxide and ethyne. Clear or not? Yes. Then students, second method of preparation is from vicinal dihalide. From vicinal dihalide. Vicinal dihalide means if halogens present at adjacent carbon. So vicinal dihalide these are CH2, CH2. If you do reaction with alcoholic KOH, I already discussed about dehydrohalogenation. Then dehydrohalogenation reaction will take place, students. And after dehydrohalogenation reaction, what will happen? From one carbon, hydrogen will remove, and from second, halogen will remove. And there will be double bond. So according to dehydrohalogenation reaction, you will write the product. What will be product? From one carbon, you will remove halogen, and from second, because it is symmetrical, so we can remove from any, and both are having halogens now. From one carbon, you will remove hydrogen. This one you will get between that, because you are eliminating halogen from this one and hydrogen from this one. Means one element from here and one element from here. Then students, after skipping these, after eliminating these, you will put double bond. So you will get, okay. Then react with sodamide. Sodamide means NaNH2. NaNH2. Then what will happen, students? Further, halogen will break from here and hydrogen will remove from here. If hydrogen will remove, then now only one hydrogen, and if from here this halogen remove, now this one only. There are only two bonds, so one element you are eliminating from here and one element you are eliminating from here. So for this, one more bond will be, this is the alkyne, ethyne it is, okay. And NaBr, these are the byproducts, plus NH2, and one hydrogen you removed from here, NH3, plus ammonium you get. So students, from vicinal dihalide you can also get the alkyne. You will do Dehydrohalogenation reaction. Already I explained mechanism of dehydrohalogenation reaction. Dehydrohalogenation reaction. From one carbon you will eliminate hydrogen and from other you will eliminate halogen. Okay, and you will put one more bond because one valency you are creating from here, one from here, then you will put double bond. Further you will do same thing, okay, in presence of the sodamide, and finally you will get alkyne. Clear or not? So these are only two methods given in your NCERT, from calcium carbide and from vicinal dihalide. Clear? Now we will discuss about acidic nature. Acidic nature of alkyne. Acidic nature of alkyne. Students, you know, when we react alkyne, I am having ethine here, okay, with sodium metal, then students, here we get sodium methine, this H get removed from sodium. Clear? Yes, and if further I use sodium metal, then this one hydrogen also removed, and it also replaced with sodium. Formation of this shows that it is acidic, because when these hydrogen will remove, then this sodium can replace this one, otherwise not. Clear or not? And students, which give H positive ions in aqueous solution, that substances are known as the acidic. That substance are known as the acidic. Here formation of these products is showing acidic behavior of the alkyne. Clear or not? Because here hydrogen replaced by sodium. Why it is replaced? Because first of all it will break, then it can attach. Clear or not? So this one is showing the acidic behavior of the alkyne. If I talk about alkene and alkyne, then students, alkynes are more acidic as compared to alkanes, and alkenes are more acidic as compared to the alkanes. Why it is? Because in case of alkyne, there is triple bond between carbon and carbon. There is triple bond between carbon and carbon. In alkene it is double, and in alkane only single bond. Then students, in case of alkyne, hybridization is sp. In case of alkene, hybridization is sp2, and in alkane sp3. So if I talk about S character, in sp, it is, if I consider total 100, then 1 S and 1 P, so 50-50. So S character is 50%. In case of sp2, if total it is 100, then students 33.33, and this is 66.66 around. So S character only 33.33. And in case of sp3, it is 25 and it is 75. So S character is 25. S character is directly proportional to the electronegativity. Directly proportional to the electronegativity. In case of alkyne, S character is maximum. So here, this S character make this carbon more electronegative. Make this carbon more electronegative. So due to more S character, this one carbon is more electronegative. So it has more tendency to attract electron towards itself. If it will attract electron towards itself, then it can release H positive easily from here. Clear or not? So why alkynes are acidic? Due to the more S character. Because alkynes, here carbon is sp hybridized and in which 50% S character, and S character is directly proportional to the electronegativity. If electronegativity S character increases, then electronegativity also increases. Means tendency to attract the electron towards itself increases. So it can attract electrons towards itself and it can release H positive ions easily. Okay, that's why alkynes are more acidic as compared to alkene, and alkenes are more acidic as compared to the alkane. Clear or not? Yes. Then students, some more reactions if we talk, like some reactions we already discussed. In chemical property, if addition of hydrogen take place, then they show the addition reaction. If addition of hydrogen in presence of nickel and palladium, this reaction you studied in preparation of alkene also. Same reaction you studied in preparation of alkane also. Now you are studying same reaction in chemical properties of alkyne. In this way you will get repeated reactions, beta. Clear or not? So first, after hydrogenation, it gives us alkene. It gives us alkene. This one bond will break, one hydrogen added to this one and one added to this one. Further hydrogenation take place in presence of nickel palladium. Then further one hydrogen goes to this one and one hydrogen goes to this one. Further one bond between carbon break. Okay, so alkyne convert into this alkene and alkene convert into the alkane. Alkane. Clear? In same way, if you have alkyne and you react with bromine, same reaction we have done yesterday in case of the alkene. That was also known as bromine test, bromine water test, or test for unsaturation. Okay, so this is also unsaturated, this is also unsaturated. If one molecule you are using, then this bond, one bond break. Clear? And one halogen goes with this one and one halogen goes with this one. If you are having one more molecule, then further decolorise this one and one halogen goes with this one. This is single bond now. and one more goes with this one. Clear? So this one is the same reaction. Test for unsaturation. Test for unsaturation. If you are having ethyne, means your hydrocarbon, if alkyne, then you will add some drop of the bromine. If this bromine color get decolorized, okay, and the bromine red orange color disappear. Means either it may be alkene or it may be alkyne. Means unsaturated bonds will be there. Either it may be alkyne or it may be alkene. But students, further you will add. If it is decolorizing, further you will add some more. Okay, so it is showing that that was alkyne. That was alkyne. Further it is decolorizing. Okay, now first alkene will form and then alkane. Clear or not? Means then saturated. So here unsaturated compound finally convert into the saturated. Okay. So breakage of the unsaturated bond take place there. Okay, and this bromine, so they can decolorize the bromine. That's why it is known as the test for unsaturation. If you are having directly saturated compound, then you add bromine, then bromine color will be intact. It will not decolorize, it will not disappear. It is showing that no double bond or triple bond is there. There are only single bonds. Clear or not? Yes. Then students, some more reactions you can do. Addition of hydrogen halide. Addition of hydrogen halide. You are having ethyne. If you react with any hydrogen halide like HBr you are having, then what will happen? With one carbon, this is symmetrical, this is symmetrical. If it is unsymmetrical, then you will follow same rule. That is the Markovnikov rule. That is the Markovnikov rule. You will attach more electronegative element to the carbon which has lesser number of the hydrogen. And if it is symmetrical, then you can attach to any. So to one you will give hydrogen and at other carbon you will attach halogen, okay, bromine, and one bond will break. Clear? If further one more unit you are having, then you will follow Markovnikov's rule. Markovnikov's rule you will follow, na? So this one carbon, this is unsaturated bond. This carbon having two hydrogen, it is having only one hydrogen. So this one having one less number, so you will attach more electronegative element to this one. Now CH2 already, so one more hydrogen, CH3, this bond further break, single CH, one Br already, one more you are adding, CH3 CH Br2. Clear or not? If you are having propine like this, 1, 2, 3, CH3, CH. So in this also, in same way you will do. You will follow Markovnikov's rule. You will follow Markovnikov's rule. So this one carbon having no hydrogen, it has lesser number. So you will attach Br to this one, and you will attach this one bond you will break and you will give hydrogen. Clear? Further, because double bond is there, further it can react. So this one carbon has two hydrogen, this one has no hydrogen. So you will attach halogen to this one, single bond, and hydrogen to this one. Clear or not? Either you want to do addition of water, addition of HBr, okay, means hydrogen halide, then you will follow Markovnikov's rule. And according to that rule, you can make product. Clear? This one also show polymerization reaction beta. Polymerization reaction what was? Like this. If you have ethyne, if you have n molecule of this, you will polymerize. Then it can also at high temperature pressures, okay, then it can also give just polyethylene. So what were you doing? CH here, this bond you are breaking now, you are breaking, there was double, so you are making single, here it is double, here it is double, then it is triple, then you will make double, CH. Polyethylene. Polyethylene. You know, they can show ozonolysis also. Ozonolysis. If you do reaction with ozone is O3. Then students, what were you doing? Between carbon and carbon bond you were breaking now. But there were double bonds. Here triple bond. So one bond you will keep as it is. Two bond you will break. One bond you will keep as it is. And you will form ozonide. You will form ozonide. Clear or not? Then you can react with Z and this one. So here this one bond you will not break. Here this one you will not break. So here what will happen? HC this one you will break, na? Wait a minute. CH, this bond as it is you will keep, CH double bond O. Yes, and you will give hydrogen to this one. Higher you will get here. Higher you will give. Here you will give hydrogen to this one beta, because this one bond here also. And CHO, you will get higher aldehyde, okay, and from here zinc oxide. Clear? So any doubt? So thank you, have a nice day.